So moving on to example, we're going to determine whether each of these relations is a function or not. And when I get a question like this, what I like to do is I like to graph these relations and then just use the vertical line test that we discussed in the video before to determine whether it's a function or not. So for example, this first relation here, well, you should right away be able to tell that this is a line, right? So if we rearrange this, this would be negative x plus 3, and it holds the form y equals mx plus b, right? So the slope is negative 1, and the b value, or the y-intercept, is 3. So the y-intercept is 3, and the slope is negative 1, meaning that it's going downwards. So the line would look something like this. And it would go on forever in both directions. Now we could also solve for this x-intercept. We can plug in 0 for y and then solve for x, and we would get 3 here. And to determine whether it's a function or not, we can just use the vertical line test. So if we took a vertical line throughout the whole graph, starting from negative infinity to positive infinity, the vertical line would always only touch one point of the graph. So we know that this relation here, this line, is a function. Now moving on to the second relation, let's figure out whether it's a function or not. And if you recall to grade 10, this here, x squared plus y squared equals 16, represents the equation of a circle, right? Because the general equation of a circle is x squared plus y squared is equal to r squared, the radius squared. So the radius in this case would be the square root of 16, which is 4. And since the radius is 4, all of the intercepts here would be 4. So this y-intercept would be 4. This y-intercept here would be negative 4. This x-intercept would be 4. And this x-intercept here would be negative 4. So drawing a circle, this would be the graph of this equation. Now you could also get these intercepts by plugging in 0 for x and y, and then solving for the other variable. You would always get plus or minus 4 for the intercepts. Either way, this is the graph of this equation. So to determine whether it's a function or not, let's just run the vertical line test on it. So when we run a vertical line through it, notice how pretty much at every point besides the x values of negative 4 and 4, there are multiple y values. The vertical line is touching twice on the graph. So we know that this relation does not pass the vertical line test, so it's not a function. Now moving on to this relation here, notice how this equation here represents a parabola, or it's a quadratic. So to graph it, there are multiple ways that you can graph it. You can complete the square, or you can factor it. I think this will factor smoothly, so let's just factor it. Two numbers that multiply to negative 6 and add up to negative 1. Well, I think x minus 3 and x plus 2 will work smoothly. So this factors into this. So we know that if we set 0 for y to solve for the x-intercepts, we would get an x-intercept of 3 here and an x-intercept of negative 2. And we know that this parabola is opening upwards because the a value in front of this x squared, the positive one, is positive. So roughly graphing this, we would have an x-intercept of 3 and x-intercept of negative 2. So we know the vertex would be somewhere down here. I don't know the exact point of it, but we're just making a rough sketch, so no need to get into too many details. So the parabola would look something like this. Again, this is not too detailed, but we're just making a rough sketch because we're just determining whether this relation is a function or not. We just want to use the vertical line test on a rough sketch. So if we take a vertical line and run it through this graph, you can tell that at every x value, the vertical line is only touching the graph once at each point. So it passes the vertical line test, so we know that this equation, this parabola, is a function. And actually, if you want to make a note, every parabola is always a function. It will always pass the vertical line test. Now, what about this final relation, this x equals y squared minus 1? Now, this one is a little bit more unique, and you probably have not seen it as much, or maybe haven't even seen it at all. So let's take a couple of steps to graph this relation. The first thing we should do is let's try to isolate for y. Let's see what happens when we isolate for y. So bring the negative 1 over, so we'll have x plus 1 equals y squared. And then to isolate for y, we got to square root both sides. So basically y is equal to the square root of x plus 1. Now notice how the square root of something can always be plus or minus. Another thing to notice is that the x value can never be less than negative 1. Because if the x value is less than negative 1, then we would have a negative in the square root, and we can't square root a negative. Now, since we're dealing with a relation that we're not too familiar with, let's make a table of values. Now, you can use any x values that are negative 1 or greater for the table. However, I use these specific x values because it's going to make the y value a smooth integer. So, an x value negative 1 plus 1 is 0, the square root of 0 is just 0. If we plug in 0 for x, we would get 0 plus 1, the square root of 1 is plus or minus 1. So the y values here are plus or minus 1. If we plug in 3 for x, we would get 4 in the square root of 4 is plus or minus 2. And then if we plugged in 8 for x, 8 plus 1 is 9, the square root of 9 is plus or minus 3. Now, taking these points and graphing them, or plotting them first, so I took all these points, I plotted them, so negative 1 and 0, and then 0, notice how the y value is plus 1 and minus 1. For an x value of 3, we have plus or minus 2 for the y values. And then for an x value of 8, we have plus or minus 3. So connecting all the dots, this graph looks something like this. Sort of like an inverted parabola that should be going through this point here. So now that we have the graph, let's run the vertical line test. Taking a vertical line, running it through the graph, it's pretty obvious that the vertical line is touching multiple points of the graph. So we know that this relation fails the vertical line test. So we know that this here is not a function. Actually, I'll write it up here. So this relation here is not a function. Again, it fails the vertical line test.